Hi everyone, this is the third video for section 4.2, 4.3. So in this video, we're just going to go through a lot of different examples of how to write out these expressions using the order of operations. So this is really an exercise in translating from English into mathematical expressions. Okay. So the first one says to multiply the sum of 3 and 4 by 5. So we know that we are going to multiply and we are multiplying by a sum. So this is kind of where all of the vocabulary that we've done is really important. So this can tell you that, well, to get the sum of 3 and 4, you have to add them first. So if we're doing an operation on the sum of these two things, well, to get the sum, we have to multiply, to get the sum, we have to add, and then we multiply this by 5. So we first take the sum, and then we multiply, which, right, taking the sum first is the same thing as saying first we add, and then we multiply. Okay, B, subtract the product of 3 and 6 from 23. So we're subtracting from 23, so it's going to be 23 minus something. And again, because we're subtracting by the product, that means that in order to get the product, we first have to multiply. So this one's really similar. The fact that there is the word product there tells you that we have to multiply first. And right, just like in part A, the fact that there was the word sum here tells us we have to add first. Okay, part C. Subtract the difference of 6 and 4 from 12. So again, when we're doing subtraction from 12, that's 12 minus something. And again, we have this word difference, which is the resulting value from subtraction. So that tells us we have to subtract first. So all of these have had this word that is the outcome of a specific operation. So that tells us we do that operation first. Just like here, number 4, we're adding the quotient. So we're adding 10 plus the quotient of 14 and 7. Okay. Keep on going. So we're adding the square of 7 to the sum of 4 and 6. So we can identify the words that tell us what operations to do first. So we're squaring 7, which is the product of 7 and 7, and the sum of 4 and 6. So we take the square of 7, and then we add it to the sum of 4 and 6. Okay? Lastly, divide 33 by the sum of 8 and 3. So again, we have this word sum here, which tells us, so we're dividing 33 by something. So just like how when you're subtracting from a number, dividing by that number, you put that number first. And we're dividing 33 by the sum of 8 and 3. Okay, so this is kind of how you translate these things. I'm going to go back through and talk about parentheses. So I put parentheses on everything, just kind of to say the parentheses always represented the parentheses always represented the quantity that was underlined in blue, right? So the sum of 3 and 4 was in these parentheses. But let's think about if these parentheses are needed or not. So if in part A, if we didn't have the parentheses, so if we had 3 plus 4 times 5, well, the order of operations would tell us that this is 3 plus 20, which is 23, which is not 7 times 5, right? We're trying to really multiply here, 7 times 5. So this one, the parentheses are needed up here. Because if we took away the parentheses, we would multiply first instead of adding first. So up here, the parentheses are needed. So the parentheses are needed here. Okay, subtract the product of 3 and 6 from 23. So here, the thing that we're trying to do first is the product, and well, multiplication comes before subtraction. So in this case, the parentheses are actually not needed. right, the parentheses are actually not needed because multiplying happens first. Okay. C, we're doing subtraction in both of these cases. However, remember, if we took away these parentheses, we would do subtraction from left to right, which means that we would do 12 minus 6 first. So in order to make sure that we do 6 minus 4 first, parentheses are needed. And this comes from, we talked about it earlier, that subtraction is not associative, meaning that we need to have parentheses over what we want to do first, because if we did 12 minus 6, that's 6 minus 4 is 2, versus this is trying to get us an answer of 10. So parentheses are needed because subtraction is not associative. Okay, D, add the quotient of 14 to 7 and 10. Again, right, division would happen before this addition, so parentheses are not needed. And part E, add the square of 7 to the sum of 4 and 6. So this one, the parentheses are actually not needed. Because we know that we would evaluate this exponent before anything else, right? So that's 7 squared, so we don't need the parentheses around that. And all of the rest of the operations are just adding, and adding is associative, so it doesn't matter what order we would do it in. So parentheses are not needed here. But on the last one, again, because if we take away the parentheses, we would do division first. And we know that, well, 33 doesn't even divide into 8 evenly. So we know that that's going to be messed up. So here, the parentheses are needed because if we take this away, we change the order in which we do the operations. Okie doke. So the next example, we're talking about writing algebraic expressions to represent each quantity. So remember, expressions are not equations. None of these will have an equal sign, but they're going to be algebraic, meaning that we'll have a variable there. So we want to find the total cost of X shirts at 12 each. Well, if we have some number of shirts and they all cost $12, to find the total cost, we're just going to multiply the cost times the number of shirts. So that's 12x. Okay, the next one, we are trying to find our new body weight after losing 12 pounds of our previous W pound body weight. So we started at W and then we went down 12. So here, I'm just gonna circle all of the variables that the equations, or that these sentences give us. The next one, the number of plastic beads each of N children receives when they divide 129 plastic beads evenly. So we're taking 129 beads and dividing them among N children, which is the same thing. Well, I'll write an or here, which is the same thing as 129 over N, right? These are the same thing. So you can write them in any way you prefer. And lastly, the volume of a cube in terms of its edge length, S. So the volume of a cube, right? A cube has equal everything, right? Right, the square has equal sides and the cube has equal height. So remember that volume is length times width times height. The square tells us we have equal length and width, and the cube has the same height. So this is just going to be S cubed, where S represents length and width and height. Okay, so these are examples of writing numerical expressions and evaluating if we need parentheses or not, and then writing some algebraic expressions with variables. And that's all for this video.